Exponent laws, zero and negative exponents. The zero exponent rule states that any base, except the base of 0, with an exponent of 0 is equal to 1. The property states here that any base, if it is put to the exponent of 0, will always equal 1, as long as the base isn't 0. X cannot be 0. Example, 38 to the power of 0 is 1. Second example, negative 999 to the power of 0 is equal to 1. Negative exponent rule states that when a power has a negative exponent, take the reciprocal of the base and make the exponent positive, which means flip the base. The numerator and the denominator switch places. If you have a base that is, for example, x to the power of negative a, the base x can also be represented as a fraction, which is x over 1. Hence, x to the power of negative a is equal to x to the power x over 1 to the power of negative a. And this is important to know because when you have a number, an integer, a whole number, you understand that it turns into x over 1 to the power of negative a, so that when you are switching places, you know where the 1 comes from. Let's look at the first example here and apply that property. We have 3 to the power of negative 2, so the 3 can be represented as 3 over 1 to the power of negative 2, which is equal to, if I want to make the exponent positive, I'm going to switch the numerator and the denominator and make it a positive exponent. Now I will apply the quotient rule, where I have to, the power of the quotient rule, where I have to distribute the 2. So it is 1 to the power of 2, which is 1, over 3 to the power of 2, which is equal to 1 over 9, if you are asked to evaluate it as well. Now let's look at the next example here. When the base is a fraction, so there's a number in the numerator and the denominator, you're essentially doing the same thing, but instead of it being a 1, you now have a number, so other than 1. So the x switches places, y switches places, and then the a gets distributed to the numerator and the denominator. Let's look at example 2. I'm going to zoom in a bit. So we have 2 over 3. I'm going to flip it. So it's now 3 over 2 to the power of positive 4. And now I'm going to distribute the 4 to the 3 and the 2, following the power of a quotient rule. So it is 3 to the power of 4 divided by 2 to the power of 4. And if the question asks you to evaluate, then it would be 81 over 16. So we're going to do some questions, examples. Question 5, simplify the following exponential expressions, applying the exponent rules, then evaluate. So we have for 5a, an exponent of 0. The 0 exponent rule states anything to the power of 0 is 1. For b, we have the same base, which is 255. So applying the quotient rule, we will subtract the exponent. So it's 255, 3 minus 3, which is equal to 255 to the power of 0, which the 0 exponent rule states that it is equal to 1. So c, 5 to the power of negative 2, is equal to, I'm going to make this over 1, if that helps you visualize. It now becomes 1 over 5 to the power of positive 2. I'm going to distribute the exponent. It's 1 to the power of 5 over to the power of 2, which is 1 over 25. D, negative exponent becomes 1 over 6 to the power of 2. And if I distribute the exponent, it is now equal to 1 over 6 to the power of 2, which is 1 over 36. And then E, we have a numerator and denominator, so these two will switch places. It becomes 3 over 4 to the power of 4, positive 4. Now I'll distribute the exponent, 3 to the power of 4 and 4 to the power of 4, which is equal to 81 over 256. And we have one final question. It's a bit tricky, or it could be. If you miss it, we have here a negative and a 0 exponent, but the negative and 8 are not part of the same base. They're not in, the negative is not in a bracket. Therefore, we keep it separate. So it's really negative 8 to the power of 0, which is equal to negative